Hello everyone, in this video you are going to learn about a very important concept of rotational mechanics, moment of inertia. And you can see here moment of inertia of any object represent inertia against rotational motion of the object, and it depends upon content of matter as well as its way of distribution. So first of all, I would like to discuss moment of inertia of a point mass in a circular motion. Then I extrapolate this concept to moment of inertia for a system of particles. Once I complete this part, I will take an illustration to make you understand how the moment of inertia can be calculated in different cases. So if you talk about moment of inertia of a point mass in a circular motion, let us try to understand what this concept means. Let us suppose there is an axis of rotation about which the body is going to rotate, and we are taking a point mass m at a distance r from the axis of rotation. If this is a point mass and it is rotating about this axis of rotation, then it will perform a circular motion of radius r. Then the moment of inertia of this point mass about this given axis of rotation is defined as product of mass into a square of separation of point mass from the axis of rotation. And in this way we can define the moment of inertia of a point mass about any given axis of rotation. And from here you can very easily see that the SI unit of moment of inertia is coming out to be kilogram meter square. Now I would like to extrapolate this concept to a system of particles. So let us try to understand in this way. Let us suppose this is a given axis of rotation about which now system of particles is going to rotate, and let us suppose the system of particles consists of many particles which are at a different distance from the axis of rotation. From here m1, suppose this is m2, this is m3, and this is mn, and the separation for m1 from this axis is r1, separation for m2 from the axis is r2, separation of m3 from the axis is r3, and separation of mn from the axis is rn. Then we can define the moment of inertia of the system. I is equal to summation of mi into ri square, and where I from 1 to n. That means you have to take the first mass and product multiplied with the square of r1, then take the second mass multiplied with the square of r2, and so on, and then take the summation. You can get the moment of inertia of system of particles. Now let us try to understand this concept through an illustration. I have taken a case where two particles having masses m1 and m2 are situated in a plane perpendicular to the line AB at a distance of r1 and r2 respectively as shown. Find moment of inertia of the system about an axis passing through m1 and perpendicular to the line joining m1 and m2. Means here you can see we have to find the moment of inertia of these 2 point masses which constitute a system of particles about an axis which is passing through m1. If I want to write the moment of inertia of the system I, then I can write, since the CD is passing through m1, then the separation of the m1 from the given axis of rotation is 0. So I can write here m1 into 0 square, and m2 is at a distance of r1 plus r2. I can write here m2 into r1 plus r2 ka whole square, and this is our required answer. So I hope from this illustration you will able to understand what exactly the moment of inertia and how can we use for calculation of moment of inertia. Now as usual I am going to give you homework. So here what I am going to do, in the same illustration the question remains the same, only the find part will change. So now I am giving you here in the above illustration, find MOI about an axis passing through line joining m1 and m2, and you have to solve this question and give the answer in your comment box. All the best. Thank you.